Right, folks, welcome back for day 5 of the trig unit, but day 3, evaluating trig functions. Okay, I'm bringing back the unit circle stuff, as you can see right here. I'm going to, after kind of retiring it yesterday, so we can kind of hopefully get a better handle on evaluating the trig functions, I brought in our special right triangles as well. I'm trying to just show you how all these things kind of relate to one another. Okay, so looking at our unit circle right here, right, remember this is in the coordinate plane. There's the origin, right? This is the x-axis, this is the y-axis right here, okay? And so, there are points here on this unit circle. Remember, all of these, all of these are radii right here. So they all have a radius of, or length of 1. And so we're going to use that information to help us kind of locate these coordinates and things like that, and also help us talk about sine and cosine. So just as a quick example here, I'll kind of draw in our little triangle. Okay, right there. There's one of our right triangles, right? And it's exactly this 30, 60, 90 right triangle right there. Okay, so let me see if I can get that. There we go. Okay, so what do we know? Well, the hypotenuse is 1. This height right here is going to be 1/2, okay, and this height right here will be root 3 over, or this length right here is going to be root 3 over 2, right? Which means that this coordinate right here will be what? Well, the x-coordinate, you go out root 3 over 2, so the x-coordinate is going to be root 3 over 2. The y-coordinate is going to be this height right here, which is 1/2, so 1/2 is the answer for that. And so there's the coordinate for that point. That is 30 degrees off the x-axis. The point right here, 30 degrees, rotated around counterclockwise from the x-axis. Okay, now think about what sine and cosine would be. What is sine of 30 degrees? Well, if I go up here to my triangle, right, sine of 30 degrees is the opposite over the hypotenuse. But that hypotenuse is always going to be 1 because of our unit circle here. So in other words, it's always just going to be this number. But this number is describing a height. And so this right here is the sine. Oh, no, sorry. The height would be the y-axis, y-coordinate. So that's going to be the sine of 30 degrees. Likewise, what is cosine of 30 degrees? Well, cosine is adjacent over hypotenuse. So it's always going to be this horizontal distance, which is the x-coordinate, right, over the hypotenuse. But the hypotenuse will always be 1 because, again, we're talking about the unit circle. So guess what? This is the cosine of 30 degrees. And this is going to be true in general. The sine is going to be the y-coordinate on that unit circle, and the cosine will always end up being the x-coordinate on the unit circle. So we can continue on here, right? So I'll erase all this stuff here. All right, and we can talk about, for example, this point right here. So again, we'll do sine and cosine here. Now we've got our 45, 45, 90. Okay, which means that this length right here is going to be root 2 over 2, and this length right here is going to be root 2 over 2, again, just from those two things right there. And so what's this coordinate going to be? Well, we're going right root 2 over 2, and we're going up root 2 over 2. And again, this is going to be cosine of 45, and this is sine of 45 degrees. Okay? So, last one here. We didn't talk about this other triangle right here, but this one right here, what kind of special right triangle is this? Well, it's got this 60-degree angle. Okay, so it's another 30, 60, 90, but it's just oriented a little bit different, right? Now we're going 1/2 this way and root 3 over 2 this way. And so the coordinate will be 1/2 comma root 3 over 2, where again, cosine of 60 degrees gives us this 1/2, and sine of 60 degrees gives us that root 3 over 2. Okay, so in other words, wow, the sine is associated with the y-coordinate on the unit circle, the cosine with the x-coordinate. So, and I'll get to these other points here in just a sec, but I want to talk briefly then about these kind of angles, 0 degrees, 90 degrees, 180 degrees. How do we evaluate those, right? I mean, there's a 90-degree angle here, but again, cosine requires us to use the adjacent leg, but which leg is adjacent to the 90 degrees? They're both adjacent, right? So that's not super helpful. And in fact, what we're going to use is this idea of the unit circle. If you locate 90 degrees on the unit circle is right here, right? That's that angle. And what is the coordinate of the point here? Well, the x-coordinate hopefully should be very easy for you to see. This point's on the y-axis, so the x-coordinate will be 0. What will the y-coordinate be? The y-coordinate is going to be a positive 1. If we use our relationships that we learned, from these earlier problems right here, that the cosine relates to the cosine of an angle is the x-coordinate at that point on the unit circle, and then the y-coordinate is found by taking the sine of that angle. Okay, so cosine of 90 degrees, cosine of this 90 degrees right here is going to be this x-coordinate, which is just 0. And so cosine of 90 degrees would be 0. Sine of 90 degrees would be the y-coordinate at that point, which is just 1. And that's true. If you type in your calculator, if you're in degree mode, type in your calculator, you'll get that answer. Okay, what about sine of 0 degrees? Well, here's the 0 degree angle right here. What's the coordinate of this point? It's got coordinates 1, 0, right? The x-coordinate is 1, so in other words, cosine of 0 is that 1, and then sine of 0 is going to be 0. Okay, and so we'll just put 0 right there. Well, okay, there we go. And so sine of 0 is 0. Okay, and you get the other points over here. So at 180, we'll have the point -1, 0. But now tangent. How do we evaluate tangent? Well, that's the other thing right here, right? We had a way to figure out what cosine was. It's the x-coordinate on the unit circle. We have a way to figure out sine. That's the y-coordinate on the unit circle. What about tangent? Well, tangent is equal to sine of theta over cosine of theta, which then we know what sine and cosine are. Y over x. So it's going to be the y-coordinate divided by the x-coordinate for the tangent there. Okay, so tangent of 180 degrees, well, what's the y-coordinate there? The y-coordinate is 0. And what's the x-coordinate? -1. And so we get 0 for tangent. Okay, notice if we did the tangent of 90 degrees, okay, what would that be? Well, that's going to be the y-coordinate of 1 over the x-coordinate of 0, which means we get undefined. And yes, that means that there's an asymptote there. And when we get to the graphing of the tangent, you will see that there are asymptotes in its graph and stuff like that. Okay, so that's another way we'll be able to evaluate the unit circle. Now, how is this helpful? Because you're like, well, Mr. Wid, I could memorize like all this stuff. I mean, yeah, potentially. I mean, there's only really 3 numbers well, I guess 5 numbers you have to remember. 1 and 0, but those are kind of easy to pick out because they're just on the unit circle. You have to remember root 3, root 2 over 2, and 1/2, right? And then these just repeat all around our unit circle here. Imagine reflecting these points over to these right here. Okay, so like, for example, reflecting this point, it would reflect over to this point right here. Okay, but instead it would be a negative root 3 over 2 because we're going in the opposite direction to the left, but the y-coordinate will still be 1/2, right? Reflecting this point over, the x-coordinate, again, would be a negative root 2 over 2, but the y-coordinate will be root 2 over 2. Okay, and then this point right here, we would reflect this over. Again, -1/2 would be the x-coordinate, and then root 3 over 2 would be the y-coordinate. Okay, and then you can reflect all of these down to here, right? To these 2 quadrants. And so this will be then negative root 3 over 2 comma -1/2. Negative root 2 over 2, comma negative root 2 over 2. And then this will be -1/2, comma negative root 3 over 2. And then this will be positive 1/2. So the x-coordinate will stay positive, but it's the y-coordinate now that is opposite because you're reflecting over that x-axis there. Okay. And then lastly here, we would have root 3 over 2, comma -1/2, like that. Okay, now how is this helpful? Well, look at all these reference angles that I drew, right? So, for example, this is a 30 degree, this is a 45 degree, this is a 60 degree angle, this is 90 degrees, right? This is 120 degrees, but its reference angle is 60, right? This is 135 degrees, but its reference angle, its, angle to the x-axis there is 45. And this angle right here is 210, too far, is 150 degrees, and its reference angle is 30 degrees, okay? And so evaluating sine of 150 is just like evaluating sine of 30, and you look at the y coordinate there, 1/2. If you want to do cosine of 150, it's just like evaluating cosine of 30. Cosine of 150 would give you the negative root 3 over 2. So this takes care of those sines too. You don't have to worry about that. All students take calculus stuff I saw yesterday. Okay, so this is 210 degrees. This is 225 degrees. Okay, this is 240 degrees. This is already the 270. You can see right there. Excuse me, this is 300 degrees. This is 315 degrees, and this is 330 degrees. Again, with these reference angles of 60 here, 45 here, 30 degrees here, because it takes 60 to get from there to there, or 45 to get from there to there, or 30 to get from there to there, right? And then likewise here. This takes 60 degrees to go this way, and so again, the reference angle here is 60 degrees, this one's 45 degrees, and this one's 30 degrees, okay? And I'll put this coordinate right here of 0, -1. All right, so that's one way you can use the unit circle to kind of help you here, okay? You take sine of your angle, you locate wherever that angle is. Let's say you want to do sine of 300 degrees. Sine of 300 degrees, it's the y coordinate because it's sine, so you get negative root 3 over 2 is your answer. Okay, so if you also want to use the unit circle to help you with that, you can. And the unit circle also helps you evaluate these trig ratios right here. You know, cosine of 180, cosine is the x-coordinate, so it's just -1. Cosine of 180 is -1, okay? If you want to do, you know, tangent of 270 degrees, tangent of 270 is sine of 270 over cosine of 270. Sine, the y-coordinate is -1, cosine, the x-coordinate is 0. So again, it's undefined. All right. Okay, I took a little bit longer than I wanted to there, but that was just a quick, you know, kind of like reintroduction of that, hopefully to help you out a little bit more. Don't worry, you'll see it again in pre-calculus if you take pre-calculus or algebra 3, and you'll see it again in calculus 2. So hopefully you'll be able to get it down better there too. Okay, and we'll practice this more as we go because we're going to be using these numbers and stuff. But it's super important that you can do this without a calculator. Okay, of course, my quizzes and stuff for this unit will be on with calculator active. Just make sure you can switch between degrees and radians and stuff like that. Okay, evaluating trig functions with radians. What do we do? Well, option 1 is to convert to degrees and then evaluate. Okay, so pi over 6, you can just use that, you know, formula, pi over 6 times 180 over pi, and you just simplify. So the pi's cancel, 180 divided by 6 is 30 degrees. So this is really like evaluating sine of 30 degrees. Okay, pi over 4 times 180 over pi, it's 45 degrees, so this is like evaluating tangent of 45 degrees. Pi over 3 times 180 over pi gives us 60 degrees. So again, it's like evaluating cosine of 60. 5 pi over 6. Well, if pi over 6 was 30 degrees, then 5 of those pi over 6s will be 150 degrees, right? So again, then you can just evaluate like a sine of 150. Okay, tangent of 7 pi over 4. Again, if pi over 4 was 45, then 7 of those 45s will be 315 degrees. Okay, and again, just do tangent of 315 for this one. Cosine of 4 pi over 3. Again, pi over 3 was 60, so 4 of those pi over 3s, 4 times 60, 240 degrees. So you can evaluate this like it's 240. Pi over 2, well, you have to maybe figure this one out, times 180 over pi. Okay, the pi's cancel, 2 and 180 simplify to 90, so it's 90 degrees. Okay, so it's just sine of 90 degrees. Cosine of pi, well, pi times 180 over pi, the pi's cancel, you're just left with 180 degrees. So again, evaluate from there, cosine of 180. And then 3 pi over 2, well, if 1 pi over 2 was 90 degrees, 3 of those pi over 2s is going to be 3 times 90, 270 degrees. Okay, and then you can evaluate from there. And again, just like we did yesterday. So, you know, sine of 30 degrees, you can go up and use the unit, the reference triangles here if you want to. So sine of 30 would be opposite 1/2 over 1. So it's going to be just 1/2. Or sine of 30 degrees, the y-coordinate is 1/2. Okay, so you can also use that unit circle stuff there too. Your 2 options there, and we get 1/2. Okay, tangent of pi over 4, again, you can use the reference triangles if you want to. Tangent is opposite over adjacent, which is root 2 over 2 over root 2 over 2, so it's just 1. Or you can go up here to the unit circle and you can see again that its tangent is sine over cosine, so it'll be root 2 over 2 divided by root 2 over 2, which is just 1 again. Okay, so you get 1 there. All right, cosine of 60 degrees or pi over 3. Again, you can use the unit circle up here, the reference triangle. So cosine of 60, cosine is adjacent, so 1/2 over hypotenuse of 1, so it's 1/2. Or you can go up to 60 degrees here on the unit circle, and cosine's the x-coordinate, 1/2 as well. Okay, so it's 2 different ways to do the same thing. Okay, and we can continue on, right? So 150, you can like use the reference angle there. Okay, so the reference angle is 30 degrees. So then we would use sine of 30, and then you determine the sine, S-I-G-N, whether it's positive or negative based on the quadrant. So 150 is in this quadrant right here. All are positive in quadrant 1, sine's positive in quadrant 2, tangent's positive in quadrant 3, cosine's positive in quadrant 4. And so then sine being positive in quadrant 2 means that our answer is going to be positive. And sine of 30 degrees, what we just saw up here, is 1/2, right? So it just gives us 1/2. Okay. By the way, this whole like sine thing where things are all positive, some sine's only positive, tangent's positive, cosine's positive, that comes from this unit circle idea here, right? Okay, if sine corresponds to the y-coordinate, then all the y-coordinates in quadrants 1 and 2 are positive, which is why sine is positive in this quadrant and in this quadrant, because that's all the y-coordinates are positive in those quadrants. If cosine corresponds to the x-coordinate, it makes sense, and that cosine's positive in these 2 quadrants, because cosine, the x-coordinates, are positive in the quadrants 1 and 4, right here. Finally, it makes sense that tangent's positive in quadrant 3 and quadrant 1, because tangent, well, of course, y divided by x, the y-coordinates divided by the x-coordinates, positive divided by positive will be positive in that first quadrant, but then a negative divided by negative, the y's and x's are negative here, divide those and you get positive answers, which is why tangent's also positive here. Okay? Oops, I gotta do more there. There we go. Okay, so tangent of 7 pi over 4, which is 315. Again, the reference angle is 45, so he'll end up with a 1. But since we're 7 pi over 4, that's in quadrant 4. Okay, so that's going to be a -1. Okay, and so on and so forth, right? 4 pi over 3, the reference angle, or sorry, 240 degrees, the reference angle is 60 degrees. And so you get 1/2 is the number, and then it's 4 pi over 3, so that's in quadrant 3, which then means cosine's negative. Okay, and then so on and so forth. Sine of 90. Actually, before I move on, I want to talk one more thing here. I know this is going really long. But notice here that the radian measures, and this is option 2, evaluate the radian measure. So don't convert the radian measure, just evaluate it. And it's actually easier to determine the reference angles when you're in radians than it is in degrees. Notice here, what are the radian measures? Pi over 6, 5 pi over 6. They're both simplified, right? And they both have the same reference angle of 30 degrees, or in other words, pi over 6. So in other words, when you see that pi over 6 in your radian measure, and it's simplified, that means that pi over 6 is going to be your reference angle. Likewise here with the pi over 4s, okay? Notice that they both have the same reference angle of 45 degrees. So pi over 4 is 45 degrees. So again, it kind of clues you in that your reference angle is going to be 45 degrees. And then finally here, what's our reference angles? They were 60, and it's pi over 3, right? You both see that pi over 3 in those radian measures, so 60 degrees is the same as pi over 3. So you can use that to help you find your radian measures too. All right, let's talk about these real briefly here. Sine of 90, remember sine is the y-coordinate, so at 90 degrees, the y-coordinate is 1. So sine of 90 is 1. Okay, a cosine of pi here is pi, cosine is the x-coordinate, so -1. And then finally tangent of 270, so 270, actually I think we already did that one. Yeah, we did it right here. It was undefined. So yeah, again, there's that undefined idea. Okay, so I'm going to stop there, just about 20 minutes. I'll give you guys only a few short problems here. It's going to be just evaluating these, so it should only take you a couple minutes to do, hopefully. You know, if you need to rewatch the video or something like that, please feel free. Hope that helped, and again, please message me if you have questions. Again, we'll continue to practice this as we go about this unit, so don't fret too much if you're still unsure about some of this stuff. Just do your best. And of course, you can always use a calculator to help check your work. Make sure if you're doing radians, though, you convert your calculator back to degrees. To do that, let me just show you here real briefly. I think I've got the, yes I do. I'll show you briefly here. Press the mode button and you can see right here you can switch between radians and degrees, okay? So, you know, if you want degrees, hit enter, and now you can evaluate sine, cosine, tangent, and degrees. If you want to switch back, make sure you highlight radians and hit enter, and you can go do your thing. So I can do, you know, like sine of pi over 6. And there it is, 1/2. Okay, Thanks, guys. Have a good day. Bye.